Good morning. My name is Sudhakar. We are going to discussing about the basic manufacturing technology. In that, we are discussing about the lathe machine and its working principle and its parts, types of lathe machines, right? So, before going to discussing about the today's class, we can recall what we have learned so far. In the yesterday's session, we are discussing about the we have discussed about the rake angles, I mean tool angles, and after that tool signature or tool designation. In the rectangles, in tool angles, we have three types of angles: rake angles, clearance angles, and rake angles, clearance angles. Right? In that rake angles, we are having back rake angle and side rake angle. In back rake angle also, we are having positive rake angle and negative rake angle. In clearance angle, we are having side clearance and end clearance angles, right? So these are the angles we have discussed in the yesterday's session, right? And after that, we have discussed about the tool signature. How do we donate the tool? That will be discussed in that has been discussed in the yesterday's class, right? The tool designated by 7 components, right? And the 7 components is in the particular form, right? Those are back rake angle, side rake angle, side cutting edge, and side clearance angle, end clearance angle, end cutting edge, side cutting edge, and nose radius. Once again, I'm repeating: back rake angle, side rake angle, end clearance angle, side clearance angle, end cutting edge, side cutting edge, and nose radius. So these are the seven elements. By using these 7 elements, we are designate the lathe tool. So based on this, our tool is designated. And why do we designate this tool? So based on our operation and the manufacturing process, what are the process we are going to do on the material? So that material, so that property, that angles are very important, right? Back rectangle, side rectangle. These type of angles are very important based on the working material and the tool material. So that's why we are designated and we are uh, taking the tool, right? Example: zero back rectangle for brass material, right? So this indicates a particularly one type of cutting tool for doing the manufacturing process on the brass, right? So for this reason, we are designating the tool signature like this with the 7 elements, and each element follow the. It comprises 7 elements, and it is in sequential order, right? We do not change the order. Exactly, we have to follow that sequence, right? Once again, I'm repeating: back rectangle, side rectangle, end clearance angle, side clearance angle, end cutting edge, side cutting edge, and the nose radius, right? And including this, we have discussed about these rake angles: back rake angle, side rake angle, end clearance, side clearance, right? End cutting edge angle and side cutting edge angle. So these are have discussed in the previous session. Okay. So now we are moving to the types of production lathe, right? And working principle of turret lathe and working principle of capstan lathe. difference between turret and capstan lathe. Okay, so today we are going to discussing about the various types of production lathes, and in that we are having the special types of lathes, capstan lathe and a turret lathe. So we have to learn that the working principle of turret lathe and capstan lathe, and also difference between turret lathe and capstan lathes. Okay. These types of lathe machines we have discussed in our earlier sessions. In our starting level of subject, we have discussed the names, different names of the lathe machines, and some function. I have already told that at that time we will be discussed clearly after in our next sessions. I have told. So now we are knowing this type of lathes elaborately, right? So here you can observe that name various types of production lathes. Up to now we have discussed about the bench lathe or engine lathe, right? But these are now we are going to discussing about the production lathes. And production lathe means that production capacity increases, right? They are producing the products with less time, right? With less time, we are producing number of products. By using bench lathe or engine lathe, we are producing a product, right, very slowly. So those are not designated as production lathe. The engine lathe is the basic lathe machine, but we are now moving to the type production lathe. So production lathe means these are producing the products with less time compared to the engine lathe. So, right, after that, turret lathe and capstan lathe, we know turret lathe. Turret lathe is having a number of tools on his tool magazine. So, we don't waste the time while fixing the tools and removing the tools from the same tool post. Just we are uh, engaging the tool, already fixed tool, engage it to the particular operation. That's why we are reducing the time. Okay, so these were turret lathe and capstan lathe also under the category of production lathes. Okay, so we will be discussed in our next coming session, production lathe. So uh, up to now we know about the engine lathe, right? Now we are going to discussing about the what is production lathe, right? So observe here, it is a modification of engine lathe. Some modifications have done on engine lathe that will be called as a production lathe. Why we are modified that engine lathe? Because an engine lathe, it is a old machine processing, it doing one product at one time, right? And workpiece loading and unloading and tool holding and unloading. These are very time taking processes. That's why we are giving some modifications on the engine lathe, right? So after giving some modifications on engine lathe, what we are getting, so production may be increases. Production is increases. Right? Its production is increases. That's why some modification of engine lathe to meet our production demands, and also it is suitable for mass and batch production. Right. So production lathe is also suitable for mass and batch production. Batch means the similar type of operations on the products, right? Similar type of operations. Batch production means that may be the products not be similar, but the operations are similar. So that's why they are called as batch production. And mass production means objects are similar, right? If we are manufacturing some a tool, right? Some knurling tool or drill bit, some drill bit. So some 8 mm dia drill bit. So mass production means we are producing 8 mm dia bits number of products. 8 dia, number of qubits we are produced. That's why it is called mass production, right? Now, batch production. Batch means the same operations has been done, but the product should not be same. Product's size also should not be same, right, with the another product. But the operations on that product should be same. That means if we are if we in our manufacturing process we need uh, turning, drilling, pouring, and reaming for a particular product, right? So it is in some size, such as suppose 12 dia or 40 dia, right? So that is our first product. In the second product, our product is its diameter is 20 only, right? It diameter 20 only, but the operations need on the product is turning, drilling, boring, and reaming. So for first product and second product, the operations are same. Both our operations are same, right? But the product size are not same. So it is called batch production. But for mass production, taking same example, for 40 dia material only, entire tools, entire work pieces are all in the size of 40 only. That is called mass production. So what we are, why we are leading this point means here a production lathe is a modification of engine lathe. It is made to meet our production demands. So by the engine lathe, we are not getting our production demands because the customer need is increases, but here our production is producing the products are less, and the time taking is more for producing the products. That's why we are making some modifications on engine lathe. Okay, and to hold machine complicated jobs. In engine lathe, we are having different types of work holding devices to hold the work pieces, right? If we are giving some modifications on engine lathe, it can be easily hold and machining the complicated jobs. So that jobs may be based on their material properties or based on their size or based on their shape. Right? That's why they are complicated. So these complicated jobs are manufactured or taken on the production lathe, right? And to keep them in continuous production lines, right? So for holding knot and machining, not only doing that, it also keep them in continuous production lines. So these are all about the production lathe. A production lathe is a modification of engine lathe. It is the modification of engine lathe, and why we are modified to meet our production demands. After modifying, what we are getting is suitable for mass and batch production, right? And not only suitable for mass and batch production, and also it is to hold machine complicated jobs, right? And to keep them in continuous production lines, right? So this is about the production lathe, right? And also we are having some important points, right? So after that, production lathe and conventional engine lathe, what we are getting the forward in production lathe, we have already discussed, it can hold complicated jobs. Production lathes are hold the complicated jobs. And here setting time is reduced, setting times reduced, and minimize production time, minimize production time. Component accuracy is more. One worker can look after more than one machine at a time, have high production rates. So observe these all points as we have already discussed that it can hold complicated jobs and setting times reduced. Why the setting times reduced? Because we are giving some modifications. That modifications are what? What are that modifications that will be discussed in our next session, next class, next slides, right? So just we have to remember this point. Setting times are reduced and minimize production rates. Sorry, production time. Production rate means so different. Minimize the production time. If the time is reduced, the production time is reduced, right? Setting time is reduced and the production time also minimized. So productivity increases. Based on these 2 points, we can easily tell that the productivity increases. Productivity means a number of products produced with less time. Number of products produced in the less time. So that production time is increased, and accuracy also more. By doing this, some modifications on children length, accuracy also more, and by doing some modifications, one worker manpower also we can reduce, right? So one worker can lift after more than one machine at a time. We can handle more number of machines at a time by production rates, and it is have high production rates, right? I have already told that the production rate increases because the setting times reduced and the minimized production time. Here setting times means work loading and unloading and tool changing times, right? These are work loading and unloading and tool changing times. That's why they are called it as setting times. They are reduced and have a high production rates. So observe in this picture, we are observed that conventional lathe, that is called ancient lathe, right? It is observed in our first sessions, conventional lathe. Okay, we have tail stock, we have tool post and carriage, everything we have clear now, right? So this is about conventional lathe. Next, we are moving to special purpose lathe, that is the types of production lathes. Crankshaft turning lathes, wheel turning lathes, camshaft turning lathes. What are those special purpose lathes? Crankshaft turning lathes, wheel turning lathes, camshaft turning lathes. Including these types of production lathes, and we have already learned this. Automatic lathes, we are well known about these names. Automatic lathes, semi-automatic lathes, turret lathes, capstan lathes, numerically controlled lathes, computerized numerical controlled lathes. Okay, automatic lathes, semi-automatic lathe, turret lathe, capstan lathe, numerically controlled lathes, computerized numerically controlled lathes, right? CNC and NC. Okay. Turret lathe. It is designed for short, continuous runs, right? Observe the turret lathe in the figure. Okay. In this turret lathe, the tailstock is replaced with the turret magazine. In that turret magazine, we are having different types of tools fixed, right? Turret lathe. Why the turret lathe is designed? It is designed for short continuous runs. Turret is mounted in a place of tailstock. Where it is mounted? It is mounted in place of tailstock, right? In the turret lathe, we are not observed that tailstock. And indexable square tool post on cross slide. Indexable square tool post. Generally, we are using the square tool post on cross slide for fixing the cutting tools. In this turret lathe, indexable square tool post, right? Indexable means for indexing. So some particular some arrangement is there. Some arrangement is there. So whenever that required, it will be accessible. So that's why it is called as a indexable square post. Okay, and it is suitable for drilling, countersinking, reaming, tapping operations. Okay, so we can easily tell that the turret is mounted in the place of tailstock. So generally tailstock place we are fixing the drill bits, reamers, okay, or boring tools. So that's why turret lathe is suitable for drilling operation, countersinking operation, reaming operation and trapping operation. Drilling means we know already that we are the drilling means it produces the holes by using the drill bits. Counter sinking, right? It is also a boring operation, but we are getting different diameters. Right? One is enlarged and another one is compared to this diameter, it is very small. Next, reaming. Reamer. Reaming operation means it is a finishing operation. Okay. Tapping means internal threads. We are producing in the hole. So these are all about the turret lathe. Right. In the diagram, we are observing that the turret lathe. Right. In the turret lathe, the tool, the tail stalk is placed with the turret. Tail stalk is replaced with the turret and cross. And here an indexable square tool post is there. Okay, so this is about the turret lathe, and it is suitable for producing, drilling, removing, tapping, and countersinking operations. Okay, next, in the turret lathe, we are having vertical turret lathe. This vertical turret lathe is suitable for turning large components like motor bodies. Okay, if we want to turning the large components like motor bodies, we are going for the vertical turret lathe. And turret head. The turret head is capable of moving in two axes. In this vertical turret lathe, it is having turret head and it is capable of moving in two axes. That is, cutting tool is in X direction. The workpiece is in Z direction, right? In this, turret head can move in two axes. That means workpiece is in Z direction. The turret head is moving in X and Y direction. It can be moved in two directions, right? In actually, cutting tool is only moving in X direction only. Yeah, in turning operation, we are having only two axes. One is Z direction and another one is X direction. The rotational movement we are denoting with Z direction, and cutting tool feeding is in the X direction. But the turret head is capable of moving in two axes, that is in X direction and Y direction. Okay. If table size is more than 900 mm, they are known as vertical boring mills. Right? If the table size is more than 900 mm, so that can be called as vertical boring mills. So this is the vertical turret lathe. Okay, vertical turret lathe. Vertical turret lathe is uh, large components turning operation like motor bodies, and it is having two axis motions, and if the table size is more than 900 mm, they can call as vertical boring mills. Okay, so this is the vertical turret lathe. The diagram we are observing vertical turret lathe. Okay, it can be moved in two axis direction. Pre-selector vertical lathe, pre-selector turret lathe. Drum turret lathes. It is similar to turret lathe, tool turret in the form of drum, no cross slide. Okay, so turret lathe, in turret lathe we found cross slide. Okay, indexable cross slide, but in the drum turret lathe there is no cross slide. There is no use of cross slide. Okay, but it is similar to turret lathe. Tool turret is in the form of drum. Tools are mounted on the drum structure, drum-like structure. So that's why it is called as a drum turret lathe. Turret lathe. Here there is no tool post observed here, and here drum-like structure is there. On this drum-like structure, we are having that tools, okay, cutting tools, right? So this is about the turret lathe, vertical turret lathe, reselector turret lathe, and drum turret lathe. In drum turret lathe, the tool turret in the form of drum, right? And there is no cross slide in the drum turret lathe. We have to remember this point, okay? So this is the drum turret lathe. Now capstan lathe. It is ideal for fast production of small parts, similar to turret lathe, that is also fast production for small parts. Capstan slide instead of turret slide, here capstan slide is there. Slide moves on an auxiliary slide. The auxiliary means another plane, different plane. Okay, we are having x, y, z, x, y, y, x, z, x. So these are the planes. But um, up, apart from these planes, it can move another plane. That's why that is called auxiliary plane. Here the slide moves. The slide moves on an auxiliary slide. Okay, and it is ideal for a small production of small parts, fast production of small parts. Auxiliary slide can be clamped conveniently on the machine. Auxiliary slide can be clamped conveniently on the machine bed. Okay, so this is about the capstan lathe. Here, capstan lathe, observed in the diagram. So this is the capstan slide. It is moved in auxiliary direction. So this is the headstock. Workpiece is rotated in this. So this is the tail post, and it is carriage. But only one is here. Instead of tailstock, here turret tool post is there. Turret tool magazine is there, and in the capstan lathe here we are providing a capstan lathe. Capstan, capstan slide. Capstan means it moves in an auxiliary movement. It is having auxiliary slide. Auxiliary slide can be clamped conveniently on the machine bed. Okay. Automatic lathes. Automatic lathe means it is available with single or multiple spindles. It can be operating sequences are carried out by a cam or actuator. Automatic lathes, there is no manpower. Simply they are actuating by themselves. So they are operating by a sequence of some orders are carried out. So order by order, they are sequentially they are operating. Those are operated by some mechanism that can be operated by some actuators. Okay. So in this automatic lathes, they are available in single or multiple spindles. Available with single or multiple spindles. Simultaneous multi-feature operation is its common feature. Simultaneous multi-feature operation. That means one by one operation has been done on the workpiece. One by one, right? One side is one operation has been done, another one is an operation, another operation simultaneously doing the operations on the spindles. That's why here it is available with a single or multiple spindles. So simultaneous multi-feature operation is its common feature. Manual controls are replaced by mechanism. Here, manual controls are replaced by mechanism. Automatic lathes are there is no manpower. Simply they are operated by some programming, some sequential orders, and because based on that sequential orders, the machine operates. The machine will operated by some actuators, some mechanisms. I have already told that here. Actuators take the instructions from that sequences. Based on that sequences, actuators are operated. If that actuators are operated, some mechanism is happened. With that mechanism, machine will operate. With machine will operate. There is no manpower need by doing operation. So this is the single spindle automatic lathe. Automatic lathes are available in both spindles, multiple spindles and single spindles. In the picture, we are observing that single spindle automatic lathe. And this is the multi-spindle automatic lathe. Okay. Next, copying lathes. This copying lathes are used for profile turning operations. Profile means some type of shapes, different types of shapes, different shapes. So that type of operations are based on this copying lathes profile turning. If the tool is traveling on one on that profile and another tool, some device is followed on the profile of the workpiece. From the tool is traveled on the profile and the cutting tool is also moving same on the workpiece. So by that we are getting the same similar shape on that piece. That's why these are called copying lathes. Okay, and this is used for profile turning. It is used for profile duplication on work. I've already told that profile duplication on work. Profile, some different shape is there. If we are traveled that profile, one attachment is traveled on that profile, the same traveling is on the workpiece by the cutting tool. The cutting tool is also traveled similar to that travel on that workpiece. So we are getting same profile on the workpiece. That's why it is called as a profile duplication on work, and it is also called as a copying lathe. Okay. This duplication is carried out by hydraulic or electrical copying device. I have told you one attachment is traveled on the profile. So based on the attachment traveled on the profile, our cutting tool is also traveled on the workpiece, similar to that travel movement of that attachment. So that point I have told that is a duplication process. That that duplication is carried out. That attachment which is traveled on the profile can be carried out by hydraulic or electrical copying device. Hydraulic or electrical copying device. Okay. Copying by means of a sensitive device called stylus. Now we are getting that point. Okay. Stylus. With what is that stylus? I have told you the attachment is traveled on the profile. Based on that movement of that attachment, the cutting tool is traveled on the workpiece. Now we are coming to the main point, that is The attachment is actuated by hydraulic or electrical operating, and that attachment is a one sensitive device. That sensitive device is called stylus. So here copying by means of a sensitive device. So that device is called stylus. Okay, it is a copying lens. The masterpiece is called template. Okay, the profile which are the template means, actually template means it is a predefined path. So on this template, the stylus is moving, right? So on this template, the stylus is moving. So based on that moving, our cutting tool is moving on the workpiece. Understood? Clearly telling you that first of all we are coming one by one point. Now we are getting that concluding. We are summarizing the entire statements are that stylus, which is the sensitive device, is actuated by hydraulic or electrical devices. That stylus is traveled on the template, that is predefined path. That is predefined path. If that travel is copied by the stylus and this copying is done on the workpiece by the cutting tool, right? The stylus is traveled on the template. The cutting tool is also traveled on the workpiece in a similar way, right? So that's why this this masterpiece template is again produced on the workpiece, right? That's why these are called copying lathes. Okay, so copying lathes are used for profile turning operations and profile duplication on work by copying lathes. By this copying lathes, duplication carried out by hydraulic or electrical copying device, copying by means of a sensitive device called a stylus, and the masterpiece is called a template. So this type of operations are used for shafts, axles, piston rods in batch production. I have already told you that batch production means same type of operations, same type of operations has been done on the products. Okay, right. Again told you that this copying lathes, if we want to produce the shafts, similar shafts. Okay, so shaft here, the masterpiece is the shaft. So the stylus is traveled on the shaft. Okay, we are not doing anything here. This is the automatic lathe. Copying lathes are automatic lathes. We are not doing any settings, right? Simply the stylus is traveled down the already designed, already manufactured shafts. Okay, so based on that diameter, the cutting tool also traveled on the again another uh, raw material workpiece. So similar, if the shaft is, if the movement of stylus is completed, the workpiece is also completed by that product. Okay, so this is all about the copying lathes. So this is the copying lathe diagram. In that, we have observed the special types of attachments. Okay. The next slant bed copying lathe. So slant means some slope. When the slant means we can easily tell that it is like some inclination or it is having some slope. So it is the latest version and it is have a slant bed. Latest versions have a slant bed. And why the slant bed? Slant beds are facilitates heavy duty copy turning. If we want to copy heavy duty, heavy large diameters or large profiles or heavy operations, that type of operations have been done by this slant bed copying lathe. Okay? This slant bed facilitates heavy duty copy turning, and here we are having the slant bed, right? Observe here, and we told that slant bed is having some inclination. Here it is having some inclination part. So heavy duty materials are operated on this machine. Okay, that's why we are providing this slant bed type. So this is also a copying lathe. Okay, here also we are copying the dimensions of another to manufacture with another. Chucking lathes. Chucking lathes we have already learned short workpiece machines, monoblock type bed, suitable for mass production, and it cannot accommodate if L by D ratio greater than 1. Short workpiece materials have manufactured on the checking lathes, okay, and monoblock type bed, there are monoblock type bed, and these are suitable for mass production. Mass production means similar products. Similar products are manufactured at less rate. At production rate is more for similar type of products. Okay, and it is cannot accommodate if L by D ratio greater than 1. In chucking lathes, we are manufacturing the products that first of all we are going to calculate the L by D ratio. If the L by D ratio is greater than 1, we cannot accommodate the products, right? So it is suitable for short workpiece products. Okay. So this is the front chucking lathe. So this is the check. We know already checks are for five types of checks we are having. Mm, 3-jar universal check, 4-jar independent check, magnetic check, drill check, and mandrel check. These checks are also known as work holding devices. Okay, based on the check, we are called this is as a check lathe, and check lathe is suitable for short work piece and less number of work piece, small work pieces manufactured on this check lathe. Okay. Now we are moving to the special types of lathes that is called NC lathes. These are all programmable lathes. So we will discuss about these NC lathes and CNC lathes in for our next level of our diploma. That is in third year. We are having one subject that is CAD CAM. In that subject, we are discussing about these NC lathes and CNC lathes. Okay, let me introduce these NC lathes and CNC lathes here itself in our lathe machines. So, numerically controlled lathes. NC means numerically controlled lathes. All the operations are controlled by pre-programmed numerical data. Here, the operations are controlled by some program. So, for turning, or if we are doing some operations, turning or milling or drilling, like that operations are all are some controlled by pre-programmed data. That data is we can store like a numerical data with some holes and with holes, right? So that will be clearly discussed in our next further studies. So just now we can introduce just now in lathes, all the operations are controlled by pre-programmed numerical data. Thus, data is in the form of punched tapes. How the data is stored, it is in the form of punched tapes. So this is NC lathe. Insulate machine. So the manpower, we have already told that in automatic lathe, one man is operated number of machines. Okay, so if we are having that programmable data, we can simply store that data in the machine. The machine read the program and do the particular operations on the product, right? Just we have first, just what we have to do here is in NC lathe, just we have to write the program. What are the program we need on particular operations. That program should be done by the operator. So the operator next job is to load that program on the machine. The machine is next to doing is it read that data, that program, read that program, and according to that program, it doing the manufacturing process on that product. Okay. So here the operator has to do only is the loading and unloading. It is a semi-automatic machine. That's why semi-automatic means here loading and unloading has to be done by the operator. That's why it is called as a semi-automatic lathe. Okay. CNC lathe. So compared to the CNC lathe, it is also a automatic lathe machining operation, but in that we are writing the program and the puncture tape. But here we are using a computer. Not we are writing the program on puncture tape. We are writing the program on computer. So just if any modifications have been done, has to be done while doing the operations or by production demand, we can simply change the program, right? By doing the change in the program, we can easily modify the product. But in the NC machines, we are not changing the uh, program in between. If we want to change the product dimensions or meeting the production demand or meeting the demand of the customers satisfaction, we have to change the entire puncture tape. We have to change the entire puncture tape. Again, we have to refreshly enter the program on that puncture tape. But in the computer numerical control machine, the program is stored in the computer itself. So we can simply change the programs. That's why we can meet the customer demands or can meet the production demands. Right? So this is the main advantage compared to the NC and CNC machines. Okay, in NC machines we are not doing any computer, only the program is stored on the puncture tape. But in CNC machines the program is stored on the computer itself. So that's why we are using. So the radical changes in industries due to this machinery. Now we are every industry using this CNC type of machines. Not only CNC lathe, any machines, CNC milling, CNC drilling, the number of production machines are CNC shapings, number of machines are operated by this computer numerical control. Okay, so radical changes in industries due to this machinery. Features. Features of CNC lathe is it is having variable speed headstock. We know the speed headstock may be rotated at variable speeds by the gear attachments, gear mechanisms and pulley mechanisms and automatic tool changers, ATC we can call it as an automatic tool changer. So number of tools changed by automatically by one, whichever the by doing this, we need a automatic, to do automatic tool changes, we need a tool magazine. In the tool magazine, number of tools are stored in that tool magazine. Whenever the whatever the tool required for the particular operation, the tool is coming and doing the operation, right? Anti-friction lead screws. Here the lead screw mechanism is having anti-friction, so that's why we are reducing the friction. Okay, so this is the CNC lathe machine. Here the operator has to work only loading the data, loading the program on the computer itself, and also loading and unloading the workpiece, loading the raw material and unloading the finished product. This work has to be done by the operator, and the remaining operations all are done by the machine itself by reading the program. By reading the program, the program converts into uh, motions of the various mechanisms in that machines. The program is converted into the various mechanisms by actuators. Right? We are having different types of actuators in that machines. So by reading that, the program is operate. The program is operate that machine, CNC lathe machine. Okay. So this is all about CNC lathes. So by this, I am concluding today's session, right? So we are discussing today about the types of lathe machines. In that, different types of lathe machines we have seen: semi-automatic lathe, copying lathes, right? And bench lathe, and turret lathe, and capstan lathe, right? In the tomorrow session, we are going to discussing about the turret lathe and capstan lathe and the difference between the turret lathe and capstan lathe, right? Today I am closing this session. Thank you.